Hello everyone, welcome back to Cyber Ducky. Today we're going to learn the golden rule of route reflectors using this topology. Many engineers think the route reflectors just reflects everything to everyone. That's wrong. And there are specific rules that acts like a firewall inside an BGP network. And if you don't know it, your routes will be silently disappear. So we're going to use this topology to explain. And here you can see one ISP router and one R1 or internal router. You can say they have a neighbor relationship, iBGP neighbor relationship. ACE number is 200 and 300. And then we have R2, R3, R4. They're all in the same BGP or iBGP relationship. But the only difference is that the R2 and R4 are route reflector clients, and R3 is the route reflector clients, which means when you configure you in the R1, you are telling this one is a route reflector client and this one we don't. So what we're going to see today is when in this scenario, we want to know, since we have enabled the route reflectors on R1, how the routes are distributed. So what's going to happen here is that there isn't a golden rule for the route reflectors. What it says is that any traffic coming from, example, let me take this one. Okay, so any route is coming to R1 from eBGP relationship to iBGP. Okay, so when it comes route from here to here, this will be sent to all the iBGP neighbors. Okay, and if there is a route from iBGP, let's say this one has another route added. Let's say this one adds 10.10.10. Maybe 10/32. So this route will be sent over this R1 to iBGP, eBGP neighbor and the iBGP route, route reflector client. The same thing, if we add here another route, 30, let's say 30.30./24, something like this kind of a route be added to this route. So this will go all the way to R1. From R1 will go to eBGP neighbor, then iBGP neighbor, and iBGP neighbor here also. But the interesting point is that whatever route in the non-client, non-R route reflector client, let's say this route will not go here. And if you add another route here, let's say 40.40.40./24, this route will distributed to here via R1 and here, but this will not be shared here. So that is the golden rule of route reflectors you need to know. So anything from eBGP to iBGP will be sent to route reflector client and non-route reflector client as well. Sorry. And anything then anything coming from route reflector client to non-reflectors, it will be sent. And the same way, whatever coming from non-reflector, non-client route reflector routers also sent to all the routes, except between if you have more than one non-client route reflector clients, it won't be sent between these two routes or the routers. So that's what I wanted to highlight today. And so the golden rule, again, you can remember, is that the non-client to non-client is forbidden. So R1 received the route from R2 and it's happily sent to ISP eBGP neighbor, and it's happily sent to the client, which is route reflector client, which is R3. But when it's tried to send to Route 4, the BGP stops. Why? Because R2 is a non-client and R4 also non-client route reflector. So route reflector will never bridge two standard or the iBGP neighbors. So if you want R2 and R4 to talk, if you want R2 and R4 to talk, then we need to make them a physical connection, or we need to add them to become a route reflector client. So that is the thing I wanted to highlight today's video. And then there is a question like how then what do you call it, loop prevention will happen. There is another advanced topic there, which is I don't want to go on this video. So anyway, I hope this information is informative and helpful, and make sure to hit subscribe so that you don't miss that in the next lab if we discuss about the loop prevention in iBGP, when we bypass the split horizon function of default function. So thank you for your time. Please subscribe, comment if you have any questions. I'm happy to answer whenever possible. Thank you.